I'd like to kick things off by providing all of our listeners with some background information on Scheugenpflug and explaining why this particular webinar will be different than some others you might have attended. So let's get started. First and foremost, Scheugenpflug is an engineering company. Producing good parts at the lowest possible cost is part of our heritage. In fact, Scheugenpflug began in 1990 as a project at Siemens to improve and optimize automated dispensing for production lines. Our reputation is well established in high-volume production applications like automotive and electronics, and we've grown into a leading manufacturer of adhesive bonding, dispensing, and potting systems. Scheugenpflug is recognized throughout the industry for our expertise in dispensing highly viscous and abrasive materials. Today, Scheugenpflug employs more than 470 associates and operates multiple subsidiaries globally. Roughly 80% of our business focuses on automotive and electronic applications. So I'm sure most of you have attended webinars in the past where the presenter has in one way or another tried to get you to purchase a specific product or solution. Well, that's not what we plan on doing here. This webinar is educational. The objective is to help you better understand dispensing and how to use that information to increase manufacturing throughput and reduce costs by improving material dispensing yield in the production environment. Specific topics that will be discussed include the overall role and the yield costs play in achieving the lowest possible cost per part produced, critical factors that contribute to adhesive dispensing yield and associated costs, common challenges faced by process and manufacturing engineers in automotive dispensing applications, and important considerations when specifying an adhesive dispensing solution. First things first, before we get into the meat of this webinar, it's important to provide everyone with some high-level background information on the adhesive dispensing market. We've got a couple different statistics up on the screen courtesy of Grandview Research that provide a bit of context as to just how rapidly the material dispensing market is growing. Now, according to Grandview, the dispensing equipment sector alone will eclipse $10 billion over the next 6 years, with a revenue exceeding $3.4 billion. Primary drivers of this growth will include the increasing demand for more accurate, efficient, and automated material dispensing systems as an alternative to manual application, along with high demand for more exacting fluid formulations across the electronics, aerospace, medical, and automotive industries, which will be the focus of this webinar. Over the last decade, automobile manufacturers' drive to enhance efficiency, improve part quality, and reduce costs has increased immensely. Adhesive dispensing systems play a critical role in achieving these goals, and as a result, they have emerged as one of the fastest-growing automation devices in the production environment. Today, dispensing systems can be found at virtually every stage of the assembly process. Specific examples include potting and sealing electronics and other components from moisture and other environmental damage, applying gap fillers, thermally conductive adhesives that draw heat from electronics, installation and encapsulation of electronic components, which would be transformers, ignition coils, etc. Adhesive bonding, using adhesives to form a material bond between two or more assembly parts, and conformal coating by applying a protective finish to delicate electronic surfaces. At this point, let us turn our attention to better understanding this concept of yield costs and how yield costs impact the cost of production. Now, given its increased role in automotive manufacturing operations, properly managing the cost associated with adhesive dispensing has become critical to reducing the overall cost per part produced. Generally speaking, dispensing costs consist of 4 separate categories, and they are the initial capital cost of dispensing equipment, operating costs of dispensing equipment, yield costs, or the cost of lost yield, and lastly, waste and repurposing costs. When it comes to selecting a dispensing solution, many manufacturers use initial costs as the primary driver for their purchasing decisions. However, our involvement with over 4,500 projects worldwide reveals that the yield costs often make up the dominant fraction of the total cost of ownership. This is particularly the case in operations where expensive adhesives are needed to bond dissimilar materials or seal exposed parts, as lost yield and downtime associated with an underperforming system can quickly exceed any initial savings. As you can see on this slide, we have a relatively simple equation to demonstrate just how important yield costs are in reducing dispensing costs. as well as the overall cost to produce a part. On the top of the equation, we have the initial fixed cost of the dispensing systems and ancillary equipment, labor costs, recurring costs, and finally, yield costs. Together, these four variables make up the total dispensing costs. On the bottom of the equation, we have lifetime of the dispensing equipment, throughput rate, composite yield, and equipment utilization, which is another way of saying equipment uptime. Plugging in hypothetical values into the equation on the previous slide allows us to compare the cost of ownership per part between two different dispensing systems. In the first column on this slide, we have System A, which has an initial purchase price of $170,000 and a service contract of $21,250. In the second column, we have System B, which has a higher purchase price of $250,000 and a service contract of $31,250. System A has a 20% higher throughput than System B. However, it also exhibits a 1% lower yield. The only other difference between the two systems is the operational lifetime. System A, we are saying, has a lifetime of 3 years, while System B is 4 years. The longer lifetime can be attributed to the use of higher quality electrical and mechanical components, which is reflected in System B's higher purchase price and service contract. So when we plug all of these numbers into our dispensing cost equation, we see that despite the significantly lower purchase price and service contract, along with higher throughput, System B still produces parts that are $3.58 less expensive than System A. Over the total lifetime of the equipment, this translates into over $400,000, which is more than 5 times what the manufacturer initially saved by purchasing the less expensive dispensing system. By diving a bit further into this hypothetical example, we can see how dispensing costs are allocated. In both System A and System B, yield represented the majority of dispensing costs. In the less expensive System A, it was 70% of the total, and in System B, it was 57%. In both cases, the initial cost of purchasing the system made up less than 20% of total costs. The point we're trying to get across here is that when evaluating different dispensing systems, it's important for manufacturers to realize that the combined costs of labor, recurring costs, and initial purchase price represent only a fraction of the system's cost of ownership. Okay, now that we've familiarized ourselves with yield cost and their importance in the cost of producing a good part, let's look even deeper into factors that affect yield. As we demonstrated in our example, yield cost is often the biggest driver for dispensing system cost of ownership. And so the question then becomes, how can we improve yield in the production environment? To answer this question, we must start by looking at the different factors that impact yield costs, and they are throughput units per shift, which is another way of saying the number of functional or good units that are produced per shift. Defective units per shift, these are the units which must be scrapped because they do not meet end-user requirements. And the third factor is the dollar value of the defective or scrapped units. First, let's look at throughput units per shift. This number is impacted by a number of different factors, including scheduled downtime, assist time, and system standby time. However, in most cases, the single biggest thing that impacts throughput in the production environment is unplanned system downtime. Ironically enough, many manufacturers don't consider this when looking at dispensing system costs. The key thing for manufacturers to remember here is that the throughput units per shift declines dramatically when lower quality systems are used. The basic circuit diagram of dispensing is the same for all suppliers, but it's the quality and reliability of the system and how it is put together for a production environment that really matters. Simple design measures, such as the use of wear-resistant coatings, seals, and fittings, can drastically reduce unplanned breakdowns and downtime from rebuilds. Although dispensing systems that incorporate these added protection measures often come with a higher price tag, any costs are often quickly recouped by the operational and reliability advantages provided during the operation. The second thing we want to consider when looking at yield costs is the average number of defective units per shift. In many instances, manufacturers will simply look at the total number of parts that can be put through a dispensing system as a way to evaluate its performance. However, this does not always serve as an accurate indicator, as a portion of the parts may be defective. As mentioned previously, this is particularly the case in the operations where expensive adhesives are needed to bond dissimilar materials or seal exposed parts. In these situations, the lost yield and downtime associated with an underperforming system can quickly exceed any initial capital savings. Some commonly seen problems associated with poorly performing systems that increase the average number of defective parts per shift will be discussed on the following slides. The first thing we'll look at is mix ratio. Maintaining accurate mix ratio is perhaps the biggest challenge when dispensing two-part adhesives. In such applications, when the ratio is off, there's a high likelihood that the adhesive will not cure properly. In severe cases, it won't cure at all, resulting in a part that must be scrapped. There are several different dispensing methods to choose from: dispensing by mass or weight, dispensing by measuring time, and finally, dispensing by volume. The particular advantage of mixing by volume is that it's done so completely independently of the temperature, material supply pressure, or the viscosity of the casting resin. Volumetric dispensing through the use of piston pumps is done mechanically and is the most precise and reliable method available for maintaining accurate ratios. Moreover, since components do not react inside the dispenser, cleaning and changeover costs are minimized. Another factor that can greatly impact the number of defective units produced per shift is system operating pressure. Systems that use high pressure to flow material can damage or crush fillers and increase material density. In some applications, a breakage rate of 80% can occur. In addition to losing money as a result of the defective part, there are other consequences that filler damage can have on the manufacturer's bottom line, such as higher costs to apply the heavier fluid or adhesive. Now, another added benefit of lower pressure systems that may or may not directly impact defective units per shift is system safety. In most cases, fewer safety measures have to be taken with a lower pressure system, which can translate into shorter maintenance periods and less downtime. Overall, it's important to remember that system operating pressure will be dependent on the unique requirements of the operator, as well as chemical makeup of the adhesive. It's not a one-size-fits-all type of decision. At Scheugenpflug, we always recommend doing upfront testing to determine the impact of system operating pressure on the adhesive. Doing so allows for a dispensing system to be customized given the unique requirements of the application. Okay, moving on. Having advanced monitoring control and feedback capabilities can drastically reduce the number of defective parts per shift. Now, such capabilities enable operators to more effectively control production quality and identify problems quickly, thereby limiting damage to parts or the adhesive itself. Although the performance level required by monitoring, control, and feedback systems will ultimately be dictated by the process and user requirements, many benefits can be realized by implementing a system that provides visibility into important steps such as docking, heating, agitating, evacuating, reloading, feeding, and finally dispensing. When using abrasive or filled materials, it's important not to force the material through the dispensing system with high pressure. If you do, there's a risk that the microsphere structure will break down and render the material out of spec. A better way is to flow the material under low pressure. This often means metering at the nozzle itself. The result from a process view is overall less stress applied to the material and, in turn, reduced breakage and out-of-spec material. Our last problem that can result in an increased number of defective units is the presence of voids in applied adhesives. Eliminating air pockets in dispensed material can be very challenging, especially with cycling atmospheric conditions, which can lead to the creation of cracks in cured material. Now, one solution for minimizing air pockets is to use vacuum dispensing and degassing. These measures help material flow into small, intricate spaces, thereby improving part quality and minimizing the likelihood of lost yield. So now that we've covered throughput per shift and defective parts per shift, the next variable we have to look at when determining dispensing yield costs is the dollar value of the units produced. For low-quality parts where simple one-to-one adhesives are applied, such as construction adhesives, the dollar value of a part can be relatively low. In these cases, the monetary losses associated with lost yield and defective parts may not be significant. This, however, is not the case in more demanding applications, including those seen in the automotive production environment, where precision parts often have a wider mix ratio with exacting performance requirements. In these applications, a poorly performing dispensing system can substantially impact the manufacturer's bottom line, as the cost of any error is greatly magnified. Having seen the critical factors that affect yield as well as the common problems experienced in a production line, we can now start to consider how to best specify a dispensing system that can truly minimize the cost per good part produced. Overall, the most important thing we want listeners to take away from our discussion today is that the adhesive bonding and potting processes have a major impact on the overall cost of a part produced in manufacturing operations. Even the slightest deviations or inhomogeneities in the dispensing and potting processes can significantly compromise the quality and service life of components. Ultimately, determining which dispensing solution is the right one for a particular application depends on a number of factors. In addition to the equipment itself, the materials used, the user potting requirements, the potting properties, and the integration of adhesive bonding, dispensing and potting processes into the production environment all play an important role. In our experience, too often do designers select the material first and then look how to automate the process. A good analogy here is golf. Weekend duffers buy golf clubs first and golf balls second. Pros, on the other hand, consider the ball and club as a combination and look to optimize this combination for maximum effect. A key recommendation is that designers and process engineers should consider the choice of material and the dispensing technology as a concurrent choice, not two separate choices. So when specifying a dispensing system for a given application, it is not a matter of one size fits all, but rather which solution is optimal given the unique requirements of the user and the process. To fully understand the dispensability of your material, manufacturers should consider getting a lab test done. These tests greatly assist in setting expectations and enable operators to zero in on the specific type of equipment needed to flow correctly and maximize yield. The test can usually be conducted in a single day and is an invaluable step in reducing overall dispensing costs. In the end, to fully understand what your dispensing process is capable of, you really need a qualified dispensing engineer to evaluate it. At Scheugenpflug, we offer clients a free evaluation. Often, in less than 30 minutes, we can help pinpoint opportunities for improvement at both the process and material level. Simple changes, maximum results. Moreover, our sales team are all degreed engineers and are technically trained in dispensing. We can help you evaluate your existing system to look for opportunities for improvement and ensure that the solution you use provides the most value over its useful life. We'd certainly like to thank all of you for attending this webinar, and if you have any questions about today's discussion or would like to learn more about how we can help you, give us a call or send us an email. We've now reached the end of this webinar. We'd like to thank you all for attending and have yourselves a great day.